Give me a call if you want and see what they say. All right, so now, so this is the subtotal. Then I use this calculation with 40% here, and we come to that grand total there. Dwelling units, feeder and service loads. What I've done is for each of the bathrooms and the kitchen, I put in a service load or a feeder, what do they call it? Branch circuit of 20 amps.
Okay.
So that you don't pop your circuit when you're using a hair dryer. So that's all done. Also, throughout the house, we have finished the Enrique tenemos esa cosa para ver que la circuit is.
Sí.
All right. We have completed upgrading all. Of course, when the house was built, it was not grounded. It was just,
2 wires.
2 wires.
Yeah, no ground.
And so we have now finished upgrading all of the outlets, all of the lights, everything is now grounded electrical. Okay, and I told you about the bathrooms and the kitchen. Okay, we have also put in ground fault interrupt circuits in every kitchen. Well, in the kitchen and every bathroom. And also outdoors at various locations where we have the waterproof outlets, but it still has the ground fault out there. Let me see. So we have the ground fault. All right. Oh, all right. Now, and now here's the documentation also. This is for the main electrical box, and then each of the breaker boxes, what's there.
Okay.
And the breaker boxes in the swimming pool room. And then this is by floor where we have outlets and what breaker they're on and throughout the whole house.
You guys done your homework, huh?
We've been busy with the paperwork. Well, we've been busy with the actual work as well. Now, one thing I also did, a major thing, in addition to replacing various places where we had that yellow cable that's for inside the house, and replaced it with the outdoor cable. We've done that throughout the property.
Okay.
In 5 months, we managed to get some stuff done.
Sounds like it.
All right, and what else was there? Oh yes, there was a wire or cable that was here when I bought the house. Was from First Construction that went underground over to the swimming pool room.
Okay.
I don't know how the condition of that was, but I figured there's just no. It's got to be at least 50 years old. So what I did.
So you replaced it?
I replaced it with which one was these? Anyway, I replaced it with an 8-gauge outdoor cable that goes all the way down around along the fence to the pool room.
¿Cuál es el cable que va
Put it in
abajo?
the conduit?
El que va abajo de la piscina?
Just gray cabling.
He said it's this one, Michael.
Yeah.
That one? All right. Now, yeah, if
You
that's
don't want to do that.
okay.
That's gotta be protected.
All right. It said on it also that I wasn't sure that was right, but it said on here that I can bury it 2 feet deep.
If it's direct burial cable, then and it says that's fine.
Okay, but it also said that it could be exposed to sunshine.
Yeah, but you don't want it to be in an area that could be damaged. All right, so something like that is like if you had it underneath a patio cover, it's up high, you're not going to be able to step on it or pull on it or hang something from it.
Okay.
But if it's low, then it can't be that way. It's got to be protected.
Okay. Right now it's just run on the fence, but we can simply dig a trench and put it 2 feet down on basically the same route. We can go have a look
You
at
can
it.
do that, or if you put it in a conduit.
A conduit.
The conduit you want to be probably 3/4 inch. It's just one cable.
Yeah.
Yeah, probably a 3/4 inch conduit will work. Sometimes Yeah, 3/4 inch and 1 inch conduit work.
That would probably be easier then, wouldn't it, than putting it underground?
I would tend to think so.
Yeah. Okay.
You typically don't want those in conduit, but because of the nature of the beast, and it's only one cable, you won't have a problem.
Okay. Let's see. In addition to this document, so we'll get back with you about whether or not I can take that number and multiply it by 0.75. Okay. In addition to this document, now we also did a load summary of all of the circuit breakers. Circuit breaker box by circuit breaker box.
So
and
let
this
me
corresponds.
if I could kind of break into your thoughts now, Mike. So on the sub panels, what size feeder is each one being fed from? So let's say you have a couple of sub panels, right?
Yeah, there are eight gauge wire going to each sub panel.
Okay.
Enrique is 8 gauge le cable que va a los panos.
Sure.
8. Yeah.
Okay.
Sure.
Well, before you continue, so typically, let's see here. I think a number 8 typically is 40 amps. So on each sub panel, have you figured out what the load is on each sub panel?
Yeah. Where's that? Well, that's what this is.
Okay,
That's
so
the
show me-
load summary for each sub panel.
Okay, so show me where the actual load is. You
The
have
main
it all
load?
written down. Okay, hold on. So you have all these written down, right?
Mhm.
Okay, and like in the front here, see how you've done a calculation where it comes up with 108?
Yeah.
Okay, so on these sub panels here, what you have to do is you have to figure out what the load is per sub panel,
Mhm.
and then what your amperage is.
So that would be down here where we are
Just like you've
adding
done,
this up.
exactly, just like what you've done over here,
Uh-huh.
right?
Okay.
This is what you're going to do right here.
Panel
so this
by
one,
panel.
Exactly. So this one here is for the main service panel.
Mhm.
Okay.
Mhm.
So because that main service panel has feeders to each sub panel, you now have to know what size feeder.
Grand total is.
Yeah. What size feeder you need to have to be able to supply that sub panel.
Uh-huh.
Does that make sense?
Yes.
So that's what you need to have now.
Okay, so that would be filling in this information here: size, number, type, blah blah blah.
Well, this
We
is
need to-
again. This is the one that you're looking for is the feeder. It's not the service now. Now you're doing the feeder.
the feeders,
And
and it's just a matter of adding this up.
yeah, it's
Okay.
a matter of doing your load calcs like you did on the front page.
Where would I write that total number? There or?
Let's see. So here's your. So this is your bus right here. Okay, that would be the when you open up this sub panel,
Mhm.
you're going to find that it'll say bus panel of 100 amps or 60 amps or 30 amps. Okay, that'll tell you what that box is designed for. All right. Then you're going to have. Let's see here. It doesn't show where the load would be placed. Let's see here. Oops. All right.
This would be the wire
This is the
going
wire size.
to
Exactly.
the
This
box.
is the feeder size, and here this is just you have a single phase. That's what that stands for. So it's just a single phase, 120 volts. It doesn't say anything about amps, so you could just probably pencil something in over here to say amperage.
Okay.
So what you're doing is you're tallying this up, and you're coming up with this number here, your total load
Mhm.
for this particular sub panel.
Mhm.
Right, and each one would be done that way,
Mhm.
and that way you know the size of your feeder. So
Okay.
I don't think the number 8 is the proper number.
8 gauge is too small, or
Probably too small on some, not
well,
all.
that one I was talking about just goes to the swimming pool where there's a pump and lighting down there.
So anything less than 40, you're probably okay on that. Sometimes, not to muddle this up a little bit, if it's a real long distance,
It is.
you lose some of the amperage. So
Mhm.
sometimes you have to upsize it.
250 feet.
Okay, so let's say that only needed a 20 amp, but you have a number 4 conductor or number 8 conductor running out there that typically would supply a 40 amps. You're probably okay. I don't know what you're pulling out there, but if you're able to
2
say,
horsepower Oh, somewhere here, I even remember where they said that 2 horsepower pump is equivalent to. Oh, that's where we got this.
Your circuit
That
breaker.
number.
Okay, your circuit breaker that's feeding that. Have you figured out what that circuit breaker size needs to be
For the pump.
for the pump?
2 horsepower is drawing 8,000 volt amps
Okay.
for a 2 horsepower pump.
Okay. And then what size circuit breaker would you have on that?
I would have to look that one up.
Okay, so here's where we go with that.
Mhm.
So we have to figure out what size circuit breaker is required. Okay. And then based off of that, that'll give us a size of what the conductor needed to be.
Mhm.
Okay. Then we think about the distance because you're going to have amperage start to decrease because of the length.
Yes.
So it's called derating,
Mhm.
right? And then sometimes you might have, I'm just going to use this as an illustration. So let's say it's a 20 amp circuit breaker. Typically you would only need to have a number 12 gauge to supply that, but because of the length, you would have to increase the size of the conductor.
Yeah.
So for this case, for the argument's sake, if you had a number 8, it would work because of the length. Okay,
Yeah.
so you upsize the conductor to be able to allow for the decrease in
So
in
it
run.
sounds like the 8 gauge would do the job
Predicated on the size of the circuit breaker that's required for that pump.
for that pump, 2
So you-
horsepower pump.
So you have to figure out what your circuit breaker. It could be a 40 amp. Okay, a lot of these pumps are 40 amps.
Uh-huh.
So with a 40 amp, you might find that number 8. I'd have to go back and look at the table, and I believe the number 8 is for 40 amps.
Oh
That's-
yeah, but
that's-
it's a 120 volts pump.
That doesn't matter. We're just talking about amperage right now.
Yeah, but doesn't if you double the voltage, doesn't that reduce the amperage flow because you're at 240 instead of 120?
I'm gonna base it off of the actual amperage itself. So if you're looking at a 40 amp circuit breaker out there and you have a number 8 and number 8's rated for 40 amps, now the concern would be the length, and you have to derate the conductor because of the size or the length that it's
Yeah.
being ran out there.
Which is 250 feet.
Okay.
Okay.
So there is a concern.
All right. So one other question. This is what I found on the internet, and plus the electrical code. Is there another document that I need to fill out? This is it. This has got it.
We're getting there. It's just now a couple of things like
Yeah,
I mentioned.
yeah.
Figure out what we need on the feeder size.
Okay.
We need to figure out what size service panel you have. If you're pulling 108 amps total, if you figured everything out correctly, and that panel down there is 200 amps.
But I might be able to multiply this by 0.75,
Mhm.
depending on,
Mhm.
yeah, which would put us down below 100 amps. Isn't a 100 ampere panel pretty much the standard?
Any more people are going 125 and 200, and the reason behind that is because a lot of people are putting in solar,
Yeah.
and a lot of people have a lot of equipment, so 125, 200 amps are kind of a lot, what you see out there, but the minimum is 100 amps.
Minimum 100. I've got quite a bunch of stuff running, so
Mhm.
I wouldn't mind at all upgrading it just
Well,
to have it.
if it's not 200, I'd be really, if I were in your shoes, I
Put
would
it up to
yeah,
200.
Yeah.
Look it up.
When you do that, there's a little bit of a process. You have to get the San Diego City Planners address, SDG&E,
Mm-hmm.
and they come out and they say, okay, this is where you're going to locate it, either be in the same spot or be relocated. Okay, they'll draw up a plan for you, and they'll say, okay, Mike, here's your plans from us. Then you take that document and you go down to the city, and then you ask for a utility permit, and you say, I need a service panel upgrade. They're going to ask for your SDG&E planner. That's the paper that SDG&E gave you. Now you hand it to the building department, and now they attach that to the permit, and that's how you get your permit for a service upgrade.
Oh, I didn't know that.
Yeah.
All right. This of course is on a completely different inspection. The installation of the water heater
Mm-hmm.
and all the upgrading of the gas lines. Based on that, I need to upgrade the size of the gas meter.
Mhm.
And I'm working on that.
Mhm.
Do I need to get a permit to put up.
You'll need to let them know that, hey, look, and I need to upgrade the gas meter.
Oh, I've let them know that, and they have in fact sent me quite a bit of documentation on how to do that.
Okay.
And I'm in the middle of doing that.
The gas meter is kind of a different animal. You don't have to go. Because the gas meter or the gas line, I believe, is on this permit. The one that you have?
Yes.
Okay.
For the installation of the water. Yeah.
So you don't need to pull another permit for the gas.
Okay.
But because the service panel is something new, okay, it's not part of this permit, the service upgrade would require a permit.
Look it up.
Yeah. But both of those would require SDG&E, collaboration.
Yeah. Oh,
comments.
yes. Yes. They gave me a nice bunch of information about how to do the gas meter. I don't know if you want to even take a look at what I've been doing. It's
Well,
the
I've
difference.
seen it down there a couple times. When it's ready for inspection, so be it. But you guys are working on it.
Yeah.
What I'll do is I'll make a note. I'll try to give you a call. I have your phone number. I'll try to get back. I'll try to get back to you today in regards to the numbers.
The percentage.
Yeah, but you guys have been here listening. You can help Mike out as for what you need to do with the sub panels and whatnot, and then other concerns about the run.
And we're getting all of this information.
Yeah.
Okay, well, we will review this a few times. I'll put it on YouTube video and
Okay.
watch it a few times.
Okay, no problem.
So do you want to, at this point, start, look, like I said, I have all of it, everything's up to grounded circuitry.
Mhm.
The branch circuits, the GFI, all kinds of GFIs are installed. Do you want to look at this stuff now?
What I like to do is we spend a little time already just jawing and trying to figure this out.
Mm-hmm.
So I don't have a lot of time now to really spend on doing the other inspection for electrical.
Okay.
What I would like to do is this. Let me run to the next jobs that I have. I'll give you a call later on today, and then based off of that, you can do your assignment as for the size of the feeders and whatnot. Okay, and that way when we come back, you already have that information. It'll be much easier for me to be able to look and see the sub panels look correct or not.
Mm-hmm.
Maybe by that time you'll have maybe a service panel upgrade. And we'll be able to get
The main.
right, and each time we'll be able to kind of do these processes. Will be the sub panel feeders, the service upgrade, the walkthrough to be able to verify that things are up to snuff.
Okay.
So that's how I would recommend it.
Okay, great.
So let's not do the inspection right now for the electrical because of the time spent already on this.
Okay, doke.
And I'll give you a call later on.
Okay, excellent. And I don't know how to put this, but you seem to be far more informative than the other guy that came out to do the inspections. So it would be really
that
good
guy.
if you were the one.
Well,
that,
we always do try to keep the same person on the project.
Okay.
The caveat to that, or the bottom line is this: is that sometimes I might be in a seminar, okay,
Yeah.
or possibly I may be on vacation, but we really try to keep the same inspector on the project.
Okay, great. Great.
And I even put notes in there too to keep me on these jobs.
Okay, excellent.
Okay,
excellent.
guys, I'm gonna keep rolling. We'll talk more then, huh?
Okay,
Thank
doke.
you, Sean.
Thank
Have a
you very
nice day.
much.
Okay.